Hello guys, welcome to this video. This is paper 2211011 May June 2020 and let's start. So question number 1. An image of a smartphone is shown. Identify one input device that is part of this smartphone. Okay, so this is your smartphone basically, and they're asking of one input device. Now you don't need to give a generic input device, but you have to give or identify an input device that is part of this smartphone. So you can write either microphone, it can be your touch screen, it can be your camera or the buttons. So you can write any. I can write microphone, which you use to give use an assistant or your Siri. Okay. Next, part B says identify two output devices that are a part of the smartphone. So firstly, speakers are present at the base. Here there are the speakers. Okay, so it can be the speakers. Okay, and the touch screen, basically it shows you all these apps and stuff. So you can also write the touch screen because it's like a monitor, but you won't write monitor here because we don't use it in the mobile phone, so we say that it's a touch screen. So touch screen can be an output device in this case. Okay, next is all smartphones have a MAC address. State what is meant by the term MAC address. So over here you can just give the full abbreviation as well, that it is media access control address. Okay, so you can simply write this, or you can also write that it is a unique address given to each device, or maybe, but even this one is good enough. Okay, then describe the structure of a MAC address. So structure, they're talking about specifically about structure, so make sure you're specific to the question. So MAC address is usually made up of hexadecimal digits. We know that it uses hexadecimal values. Okay, so it uses hexadecimal values, and you can write about the fact that the first part is the first half of it is the manufacturer number, and the second half is the identity number or the serial number of the device. Okay, so you can write that the first half is the manufacturer code, manufacturer number, while the second half is the is the serial number of the device, serial number of the device. So pretty simple. We needed 3 points, and I guess these are pretty much good. Okay, then D part says that the smartphone needs both RAM and ROM. So you have to state that why a smartphone needs RAM and ROM. So for RAM you can say that it to store the startup instructions, basically whatever the Android, it opens when you power off your phone. Okay, and then it opens up. So you can write that ROM is needed. It is needed to permanently store boot up, or you can say your startup instructions. Then for RAM you could say that it is used to store data and programs that are currently in use, because RAM is not a permanent memory. So it can be it needs RAM to store data and programs currently in use. This is very important that you write currently in use, because as soon as the mobile shuts off, you close it, so then the data is lost, okay, in RAM. So it's just storing the data and programs currently in use. Then modern smartphones can be secured with a biometric system that is built into the phone. Identify 2 biometric systems that would be suitable for securing a smartphone. You can always use a fingerprint scanner. It could be your voice recognition, or facial recognition is also a thing that is there. So I could write the 2 common terms: fingerprint scanner. Even retina scanner is there in some phones nowadays, and you can write that voice recognition. Okay. Then explain why modern smartphones are secured with a biometric system. It is to increase the level of security, because biometrics make use of the properties which are unique to an individual. So it basically adds an extra level of security, because biometric device requires properties which are unique to individual. Our fingerprint is different, our retina patterns are different, which cannot be copied by a hacker or for any malicious activity. So you can always write that since a biometric device requires it requires properties unique to individuals. It can add an extra level of security. Okay, so it's fine. Then it requires properties unique to individuals, so it can add an extra level of security. Okay, so I hope it's clear. Then question number 2 says, consider the logic statement. Okay, let's write the algebraic statement first, so then we can finally do this question. But the first step is always to write the algebraic statement over here first. So the 3 brackets are there. Okay, A NAND B. NAND is the opposite of AND, so A dot B and then bar, because NAND gate is simply as if let me draw it here. NAND gate is simply as if the AND gates inputs are there, A and B, and then they're not. So this is similar to a NAND gate. So what we do is basically A dot B, and then we put a bar over here. Okay, so this is similar to the NAND gate. Okay, then close the brackets. Or is plus, and then B XOR C, and then you close it. And not C. Not is always the bar, so you put that like this. Okay, so now as always I say that first you have to look at the brackets over here first, the separate brackets. So it's basically A NAND B. So you're not going to draw this one gate. This is not NAND gate. I was just showing you that this operation of and then the inverter is similar to a NAND gate. So you're gonna draw the NAND gate because NAND is written. Okay, so simply I'll first do it A, because this thing is being OR with this one, and the whole thing is then ANDed with this OR C. Okay, so let's see over here. A, always use a pencil while drawing this. NAND B. So I'll just take it above over here and over here. It's gonna be this thing. A and B. Okay, the gate is not good enough. Let me draw it again. Okay, fine. So this is fine. A and B, and then you have to OR it with B XOR C. So let's go B XOR C. Okay, let me put a dot over here that this wire is going there, and B XOR C. Okay. Try to draw it as neat as possible because it creates a good impression on the examiner. Okay, so make sure you draw a good one. Okay, B XOR C, and then I'm gonna OR it together. OR it together, B XOR C, right? These wires should go till here, okay? And then we're going to OR it like a rocket. Okay, it's like a rocket. Then it's dot C bar. Okay, now this is ended with C bar. Just extend this like this. Put a dot over here so you know that it's going above over here. And C bar, you can always draw a bar, not gate. It means it's not gate. So whenever there's bar or not, there is this not gate and a bar. Okay, so this thing, I'm gonna draw this. Pretty simple. You just need to know the shapes of these gates. Okay, and you're going to connect this with this X. Okay, fine. I'm going to draw it over here. Yes, it is going to connect with the AND gate over here. So this whole OR thing is ANDed with this thing. So you simply connect it with this X because they're expecting you that the X should be here. So it is your final logic gate. So they award you marks for the correct inputs because they're saying that you have to, all logic gates must have a maximum of 2 inputs. Do not attempt to simplify the logic statement. But you need to know that only the NOT gate has 1 input. So it's pretty simple then. Okay, so these were the gates that you need to use. Now we'll draw a truth table to represent the given logic statement. So let's draw it stepwise. Okay, first we have A dot B bar. So first we'll do A dot B bar and then A dot B. Okay, sorry, A dot B and then A dot B bar because we're just gonna reverse these values. And then B XOR C, and then we're going to take out this whole input together, and then we're gonna deal with C bar, and then for the final output. Okay, let's start then in the same order. A dot B, so let's do it first. 0 0 0 0 0 0 0 0 0 0. You're just gonna multiply it together. So it's pretty simple. And A dot B bar is the reverse. Always do it stepwise so there is no chance of error. Okay, so it's like 1 1 1 1 1 1 0 0. And then B XOR C. So same for XOR gate, there's the rule that when there are same inputs, then it's 0, and when they're opposite or different inputs, then it is 1. So B XOR C is basically same 0, opposite 1, same 0, opposite 1, opposite 1, same 0, opposite 1, same 0, same 0. Okay, fine. It's good, pretty good. And then A dot B bar plus B XOR C. So let's do it. We need to add these two. 1, 1, 1, 1, 1, and 0. Okay, pretty good. And now I'm gonna add it with this C bar. Okay, so where is my C bar? C is this. Let's do this. 1, 0, 1, 0, 1, 0, 1, 0. So now just add it. 1 1s are 1, 1 0s are 0, 1 1s are 1, 1 0s are 0, 1 1s are 1, 0 0, 1 1s are 1, 1 0s are 0 0s are 0. So it's basically 1 0, 1 0, 1 0, and 1 0. So pretty good. We have these this output, and I hope it is clear. Then you have this question number 3. It says Carla's computer has a USB port. Fine. Now this is again a famous question. Carla uses the USB port to connect her mobile device to her computer to transfer her photos. Give 3 benefits of using a USB port to connect the mobile device to the computer. Okay, it's pretty good that it will charge the device at the same the mobile device at the same time, because I have tried it myself. So benefit 1, you can write that it would charge the mobile, even if you're transferring your photos, the mobile device would be charging at the same time. Okay, so it's pretty good. I've tried it, so it's a really good benefit. It's not in our books, but it is a benefit. Okay, so it would charge the mobile device at the same time. Okay, charge the mobile device at the same time. Fine. And then you can also write that it can't be inserted in the wrong way around, because it has it can fit in only one way, so it can't be inserted in the wrong way. Okay, way around. Okay, and then you can write that it's a universal standard. So obviously it's compatible with many devices, and also it detects automatically if the device driver is correct device driver is installed. So, but to be short and simple, you can write that it is a universal standard. Okay, then state the type of data transmission used when transferring data using a USB port. So we have learned 2 types of data transmission, which are serial or parallel. So this USB port uses serial data transmission. Okay, simplex, half duplex, and full duplex is basically the direction of data transmission. Okay, and then part C says Carla wants to reduce the file size of the photos she has transferred to her computer. She does not want the quality of the photos to be reduced, so she uses lossless compression. Describe how lossless compression reduces the file size of the photos. So for this question, for these types of question, you always get 1 mark for writing that a compression algorithm is used. So always write this, that compression algorithm is used. This way your 1 mark is secured. Okay, this is always a point in these compression question, because it obviously uses compression algorithms. Okay, and then you can write that because it is lossless, so no data is removed, in the compression process. Removed compression process. And one more thing, you can write that because this is 4 marks, so you need to justify them. So firstly, you have told about the compression algorithms used, then lossless compression, because no data is removed in the compression process since it's lossless. And you can write that an index, because it's written that she does not want to reduce the quality of photos. So photos means that there are pixels, right? Pixels, because pixels make up the photos, right? So you can write that obviously an index of pixels is created, like an index of words is created when you are doing the compression of text files. So in the same way, an index of pixels is created. And the number of times the pixel is repeated, it's stored in a row. So in this way the compression is done, and index of pixels is created. It is just the same as in the text file. It happens that the index of the letters is created and the number of times the letter is repeated in a row is stored. Okay, number of times pixel is repeated is repeated in a row is stored. So pretty simple. So you have like 4 marks, and for here, because 4 points are justified over here. Stored. So fine. You have described it how it works. Okay. Then question number 4 says 2 error detection methods that a licensed computer uses are check digit and checksum. Give 2 similarities between the check digit and the checksum methods. Okay, so 2 similarities between check digit and checksum. So number 1, that they are both but no, wait, you can't write that they are both error detection methods, because they have already given that 2 error detection methods. So you can write that they both calculate a value from data, because from check digit is also calculated from the data, and checksum is also calculated from the data, and they're also compared, right? And they're recalculated at the receiving end. So you can write that they both report an error if they do not match, right? So you can write that number 1, they both calculate a value from data. Okay, and then they both report an error if they do not match. Fine, so this is fine. And then you have to write that in part B, that identify one other error detection method that a licensed computer could use. So describe how the method checks for error. So you can simply write about we have these 4 error detection methods in our book, which are check digit, checksum, parity check, and ARQ, automatic. And echo check is also there, but it's not what you can say, it's not an effective method of dealing in these types of error detection methods, so it's not so effective. We don't use it usually. So you can write that ARQ is simple, automatic repeat request, as the name suggests. So automatic repeat request, this is ARQ. Always know the full abbreviation. And the description is, firstly, you get always a mark over in writing the description of ARQ. Whenever you write that, it uses acknowledgement and timeout. Okay, you always get a mark for this. So always remember that it uses acknowledgement and timeout. Okay, data is sent. Okay, at the data is sent. Okay, that with the request that it is being acknowledged at the receiving end. Okay, sender sends data, okay, with the request that the receiver acknowledges that the data has been correctly transmitted or received. And if if acknowledgement is received, okay, until timeout occurs, before timeout occurs, right? So then the message is automatic. If acknowledgement is not received, okay, until the timeout occurs, then the messages, for example, wait, let me tell you. If sender, this is the sender, okay, it sends a message to the receiver with a request that the receiver should acknowledge that the data transmitted was correct, okay. But if this acknowledgement is not received within a certain time frame, then the message is automatically resent. Okay, so putting it into formal words, you can write that okay, sender sends data requiring acknowledgement from the receiver that data has been correctly received. Okay, so then what happens that the sender, obviously, it checks on the receiving data. Okay, it a check is performed on data received, okay, and then the acknowledgement is to be sent. But if acknowledgement is not received, okay, the spelling, received, if acknowledgement is not received within the set time frame, then data is sent, okay, within the set time frame, then the data is resent. Okay, so I guess it's fine. Then question number 5. Six components of a computer are given. Some parts of the central processing unit (CPU) of the von Neumann model for a computer system. Some are part of the central processing unit, okay, of the von Neumann model for a computer system. Tick to show if each component is a CPU component or is not a CPU component. So let's see. Arithmetic logic unit. Okay. It is in the von Neumann model, okay, the stored program. It is a CPU component, of course. It is in the CPU, the arithmetic and logic unit, because it carries out the calculations and data. Then hard disk drive. Hard disk drive is not a CPU component because it is internal to the computers. It's not a CPU component. It's not inside the CPU. Then memory address register, yes, it is a CPU component. Okay, RAM is not a CPU component. It is not directly accessed by the CPU. And solid state drive is also not a CPU component. These secondary storage devices are not a CPU component, right? And nor this RAM as well. Okay, and the control unit is obviously a CPU component. Then question number 6, it says that 4 scenarios are given. You have to identify the most suitable sensor for each scenario. A different sensor must be used for each scenario. Okay, so let's see the scenario first. Detecting when a person is approaching an automatic door system. It could be infrared because we all emit infrared radiation. So it could be infrared sensor. Infrared sensor. Then monitoring the pollution level in a river. You can use a pH sensor because it means that the pH would not be suitable of the water. Then it could be, obviously, whenever there's pollution, you can always use a pH sensor. Okay, and for this, checking if a tropical aquarium is 25 degrees Celsius, pretty simple, that whenever there's temperature, you always use a temperature sensor. Then counting the number of cars that cross a bridge, you can use a magnetic field sensor because these are cars. Okay, you can also use a pressure sensor as well. Okay, and a motion sensor as well because counting the number of cars that cross a bridge. So, but I'm writing a different one, that magnetic field sensor. Make sure you use the correct terms of sensors that are in your book. Okay, then question number 7, it says that Hans has a website selling comic books. Customers can create an account to buy the comic books.